Today our topic is solving systems of linear equations by graphing. So our essential question is, how can I represent and solve relationships using systems of linear equations by graphing? First off, if we're going to be graphing equations, we need to review how to graph an equation. So when it's already in slope-intercept form, y equals mx plus b, identify your m, -1/2, and identify your b, -8. We always start with our b, and that goes on our y-axis. So we're going to find -8 on our y-axis. So we count, starting in the middle of our graph, we go down 8. 1, 2, 3, 4, 5, 6, 7, 8. Right there is our y-intercept. Then we use our slope to find the next point. Slope is -1/2, so rise over run. We rise -1, that means we're going to go down 1. Run 2, we're going to go right 2. Down 1, right 2, down 1, right 2. Now, I want more points in my graph than just that. So I'm going to flip around, and instead of going down 1, right 2, I'm going to do the opposite. I'm going to go up 1, left 2. It's just flipping it around. So from here, this red point, I'm going to go up 1, left 2, up 1, left 2, up 1, left 2. And there you see I'm getting a lot more points on my graph, so I can get a nice, pretty straight line. For our second equation, it's in standard form. So our first step is we need to make it into slope-intercept form. We need to make it look like y equals mx plus b. So our first step is subtract 3x from both sides. -2y equals 4 minus 3x. Then we need to divide by -2 to get that y all by itself. Y equals 4 divided by -2 is 2. -3 divided by -2 is +3/2x. Now we can identify our m and our b, but be careful with this. M is not going to be the first number, it's going to be that number next to x. So it's going to be 3/2. Our b is going to be the number all by itself, the 2. Start with your b on your y-axis, find 2. So start in the middle of your graph, go up 2. Then use that slope. 3/2 means we're going up 3, right 2. Up 3, right 2. Up 3, right 2. Now again, if we want more points on our graph, we can flip that around. Instead of going up 3, right 2, we can go down 3, left 2. 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 Now we have many points on our graph, so we get that nice, straight, complete graph. Now for the new stuff. Systems of linear equations. 2 or more linear equations in the same variable. That just means both equations have the same variable, like y equals 2x plus 7. That has an x variable and a y variable. And 2x plus 3y equals 5. That also has an x variable and a y variable. The solution to a system of linear equations is an ordered pair, a coordinate point, x, y. You must have an ordered pair in order for your solution to be correct. There are 2 special cases though. One special case is if the lines never touch. And if we remember, we call those parallel lines. So if our lines are parallel, the solution is no solution, because they never cross each other. If they are exactly the same line, so the same line, then the solution is infinite solutions. Now that might be confusing right now, but we'll have some examples coming up soon. Find the solution by graphing. So our first step is to make sure it's in y equals mx plus b form. For our first example, these are both in the correct form. For our first equation, our m is 2, which I'm going to write as 2 over 1, and our b is 2. Start on the y-axis, go up to 2. Start in the middle of your graph, add 0, 0, go up 2, right there. Slope of 2 means we go up 2 over to the right 1. Now we also want to do the opposite. We want to go down to left 1 as well. We want to get as many points on the graph as possible. The reason for this is because if we're going to see where this second equation crosses it, we want to have all the points that we can on our graph. For our second equation, m is 4, so I'm going to say 4 over 1. B is 6. Start with your 6, your b, on the y-axis. Count up to 6, which is right here. Then our slope is up 4, right 1. Well, if I go up 4, right 1, I haven't crossed the blue line yet. So we need to flip it to down 4, left 1. Down 4, left 1. Down 4, left 1. Now we have a crossing point, but we can keep going. Connect all the points to make a nice straight line. And right here, we have our crossing point. Now we can't just circle it and leave it. We have to write our ordered pair. So our solution right here is on the x-axis we're at -2, and on the y-axis we're at -2. So -2, -2. That's where those two lines cross. For our second example, we need to make the first equation, rewrite that into slope-intercept form. So to do that, we're going to move this 3x over by subtraction. Y equals 5 minus 3x. Your b is 5, and your m is -3. So m equals -3 over 1, b equals 5. Start with that b on the y-axis. Start at the middle of your graph, count up to 5. 1, 2, 3, 4, 5. Right there is our y-intercept. Then we use our slope to get the next points. -3 means we're going to go down. 1 means we're going to go right 1. So down 3, right 1, down 3, right 1, down 3, right 1. And the pattern continues. We could also flip it and go up 3, left 1, which only gives us 1 extra point on our graph. Connect those points to make a nice straight line. Now we just need to make our second line, y equals -4. Now if you remember, this is one of those special lines. It's a horizontal line. It's going to go right to left. So all we have to do is find y equals -4 on our y-axis. So we start at the middle of our graph, count down to 4. 1, 2, 3, 4. Put a point there, and then draw a line left to right through that point. Once we've done that, we can see there's a nice pretty crossing point between our red line and our green line. That point is at 3 on our x-axis and -4 on our y-axis. So our solution to this system is 3, -4. So both of these examples were examples where there was only one solution. Now here we have our special cases. Find the solution by graphing. This first equation is in the correct form. So we can say m is 2 over 1, b is 4. Start with your b on your y-axis, go up to 4, right there. Then our slope of 2 over 1 tells us we can go up 2 over 1, or the opposite, down 2, left 1. So I can go up 2, right 1, up 2, right 1, or I can go down 2, left 1. And again, we want to get as many points on the graph as possible. The next equation, we need to change its form. We need to solve for y. So first off, we're going to minus 4x on both sides. Negative 2y equals negative 8 minus 4x. Divide by negative 2 on both sides to get y completely by itself. So we get y equals negative 8 divided by negative 2 is 4. Negative 4 divided by negative 2 is 2x. So for this equation, our b is 4, and our m is 2 over 1. Now if you look, that was the same as our first equation. So these two equations are exactly the same. We can rewrite this as y equals 2x plus 4. If you see, that's the exact same equation, which is going to give us the exact same line, which means our solution is infinite. There are infinite possibilities because the red line and the blue line, they touch at all points. They overlap at every point. All of the points on that line are solutions. Second example, y equals negative 1/3 x plus 5. So we have y equals mx plus b. M is negative 1/3. And b is 5. We start with that b on our y-axis. So we count from the origin up to 5 on our y-axis right there. Slope of negative 1/3 means we go down 1, right 3, or the opposite, up 1, left 3. Down 1, right 3, up 1, left 3. Connect your points. Second equation, we need to do some changing around. Minus x on both sides. 3y equals negative 3 minus x. Divide by 3 on both sides. We get y equals negative 3 divided by 3 is negative 1. Negative x divided by 3 is negative 1 over 3x. M is the number next to x, which is negative 1 over 3. B is the number by itself, negative 1. If you notice, our m's are the same. That means we have parallel lines. When we graph this second line, b at negative 1, right there, m is negative 1/3, which means we can go down 1, right 3, or up 1, left 3. If we follow that pattern, we are going to be graphing parallel lines, which never touch, which means for this one, we have no solution. So those two are the examples for those two special cases. All right. Thank you for watching my video, and please subscribe to my YouTube channel.